yourself some food and be like, yo, I'll email you $5 right now if you drive me nuts.
Yeah.
All right, here we go. So,
I did that once.
7.1, we're going to talk about exponent rules. It's going to be multiplying and dividing exponents. So it says, first of all, what is an exponent? Basically, an exponent means that you multiply the base by itself that many times. So if I have x squared, I'm going to take x times itself 2 times. If I have 2 to the 6th power, it means I'm going to take 2 times itself 6 times to get my answer. Okay? So on your sheet, you guys also have the big B and the little n. What I want you guys to do for the B, put the base, and the n is going to be your exponent.
I literally have the ends in my house.
You probably do.
No, I definitely do.
So the B, the big, is going to be the base. The n, the little thing, is going to be our exponent. Okay, so let's talk about the invisible exponent. So it says when an expression does not have a visible exponent, its exponent is understood to be 1. So if I just give you the variable x, you guys have to understand that that 1 is there. It's invisible. If I just give you a squared b c to the 3rd, that b, where I didn't say they're an exponent, you know that b is to the 1st power, okay? So it's understood that when there's a variable by itself, that the exponent actually is 1. So if I would give you a mathematical statement, and I would put the variable x, should you put an exponent of 1 down when I say what is the exponents in this statement? Yeah.
Would we count it off?
Oh, yeah. I would count it off if you didn't. Okay? So you will see that again, right? You're going to see that again. So product rule. Product rule. When multiplying expressions with the blank base, you blank the exponents. So you think, when multiplying expressions with the... What do you notice about these bases here? They're the what? And they're the... Those are the what? Those are the what?
Same.
Yeah, same. So when multiplying expressions with the same base, what do you do with the exponents?
Keep it.
Subtract.
Not subtract.
Add them up.
You add. So when you multiply with the same base, you can only do them, you can only multiply them together when they have the same base. You actually add the exponents together. Okay? So I was talking to Mr. Guestford, and he gave me a little mnemonic device to kind of help me remember that. You guys remember PEMDAS, right?
Yeah.
Order of operations, right? We're going to call these our power rules. What's our first power rules? We have our parentheses, right?
Exponent.
Then we have our exponents. What's after exponents?
Addition.
No. Multiply,
Yep. Multiply.
divide, then what?
Addition.
Add, subtract. So what he showed me was kind of neat. If we're multiplying our exponents, we're going to work our way down the list. So what's right under multiply?
Divide.
What's right under multiply?
Add.
Add. So that means we're going to work down the list. So if we're multiplying, we're going to add the exponents, okay? So are the bases the same? X squared times x cubed. Are the bases the same?
Yes.
Yes. Okay, so our base will remain x, and then we're going to add the exponents together. So 2 plus 3 equals 5. So it's going to be x to the 5th power. Okay? I'm going to work my way across. So here, I have 2x to the 4th times 3x to the 2nd. What am I going to do with my numbers?
Add them up.
Now, what am I going to do with my coefficients here? What do you think I'll do with my coefficients?
Divide.
My big numbers. What's it asking me to do?
Multiply.
Multiply. So I'm going to multiply those together. So what's 4 times 3? Or excuse me, 2 times 3? 6. Now I look at my exponents. I'm multiplying exponents. I work my way down. What am I going to do with the exponents? When it says to multiply, I'm going to add them. So x to the what?
6.
Okay. This is the invisible rule. The k is by itself, but really what's the exponent that goes with the k? 1.
So it's just 10.
So if I have k to the 10th times k to the first power, as I'm multiplying, work my way down, it means I'm going to add my exponents. What's that going to equal?
11.
K to the 11th power. Right? To the right, 3k to the 14th times k to the 3rd. What's that going to be?
3K 17.
3k to the 17th. Good. Are my bases the same?
No.
If my bases are not the same, I cannot multiply the exponents together, okay? Because one base is y, one base is an x, they're not the same. I cannot multiply those two together. So what I'm going to do, I'm just going to rewrite them. But how am I going to rewrite them as a final answer?
Y.
No.
Y2 X. No.
Y2 times.
Well, how do we always like to list our variables? In what order?
Order operations.
No, what? Huh? Alphabetical order. So I'm just going to rewrite it x to the 4th, y to the 2nd. Okay? We're just going to put them in alphabetical order. And my last one.
Combine the two x's.
Okay, so we're going to combine the two x's by doing what with them?
Adding.
Adding them. So what's that going to equal?
X 8 over 8.
Okay, x to the 8th power. Now, what do I do with this 3y squared?
Just put in order. Or just keep it as the same.
Just put on in, right?
Yep.
Any questions on that? Have I lost any of you guys yet?
No.
Okay. All right, so that's our product rule.
Page.
I know. So when I went to run them through the copier, page 1 didn't run off, and it went right to page 2. So I'm not real sure what happened, why it didn't print. So you're going to the quotient rule, okay? So I apologize. It was, I know, Monday morning copy issues after being off for a minute. So we're going to look at quotient rules. So quotient rule, when dividing expressions with the, what do you think? Think about your multiplication. Same base. You blank the exponents. Now think about it. Subtract. Good, Maddie. You're going to subtract the exponents. Okay? So, when you divide exponents, you actually subtract them. Only if they have the same base. Okay? So, this first one, I have x to the 3rd divided by x to the 2nd. Here's one way that you guys could look at it. You have x, 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 right? So if I take the exponents and I subtract them, what's 3 minus 2?
3 minus 2 would be x over 1.
It'd just be 1, right? So I basically would just have x left. Okay? Could you write it as x to the 1st?
Yep.
You could, but do you have to have that 1 there? No, it's that invisible, just known thing. So basically what you're looking at it, if you have 3 x's on the top, 2 x's on the 1, those will cancel out and you have 1 left. That's your subtraction, okay? So here, I have k to the 10th divided by k. If I have a k by itself, what's the invisible exponent? 1. So then if I'm dividing these two exponents, it's going to equal k to the what?
9.
Yeah, because what did you take there, Ben, to get 9?
I took the invisible 1, subtracted it, and then I got 9.
Good. So you took 10 minus 1 and got 9. So k to the 9th power.
That's above 10 minus 9 or minus 1.
Okay. Let's look at this next one. We have y to the 4th, x to the 4th divided by y to the 2nd. Are these bases the same? Are my big numbers, my big bases the same? No. If they're not the same, there is nothing I can do to this problem. So it's just going to be at x to the 4th over y to the 2nd. That's my final answer. There is nothing I can do to that. Okay? Dylan, you getting these?
Now if I'm correct, the next one is to divide.
Okay, so Ben's like, okay, so what are we going to do with this next one? With our coefficients, with our numbers out in front of our variables here, we're going to go ahead and divide those. So we're going to divide 4 divided by 2. What's 4 divided by 2?
2.
Okay? And then my exponents when I'm dividing, what do I actually do with the exponents when I'm dividing exponents?
Simplify.
Not simplify.
Sorry.
What am I going to do with those exponents to get what that equals?
Subtract.
Subtract. So I'm going to take 5 minus 2. What's 5 minus 2?
3.
Yeah.
There you go. This next example, you're going to look at your coefficients first. You're going to look at your number in front of your variable first. Can you take 2 and divide it by 4?
No.
No. But Hannah, 2 over 4, what could we do to it? Well, we can't divide it because it's going to end up being a decimal. Well, we could, but we don't want a decimal. So I'm going to leave it in fraction form. But what can I do to 2 fourths? No? Can somebody help out?
Reduce them.
Reduce them, okay? So 2 fourths can be reduced or simplified to what? 1 over 2. Okay, but I'm not finished. Now, I have to worry about my exponents. I have k to the 10th, and then my invisible rule, k, which is k to the 1st. Josh, how am I going to find what my exponents are going to equal if I'm dividing them? What am I going to do with the exponents? Subtract them. So what's my exponent?
10.
Minus,
1.
which equals?
9.
Okay, so that's going to go on the top here. So 1 k to the 9th over 2. Okay? All right, last one that we're going to look at for this particular section. So 5y to the 3rd x divided by 15y to the 2nd. What am I going to go and do with my coefficients here first, Riley? Can I divide 5 divided by 15? No. What do I do to them? Not add them. What can I do with... Hold on, let me ask this in a different way. If I have this, if I just have this, would I leave it written like that? Why not? What would I have to do to it? And divide it by what? And that's going to equal 5 divided by 5 is?
1.
And 15 divided by 5 is? Yeah. Remember, we're going to take this fraction and we're going to write it in simplest form, okay? So 5 over 15, I can't divide it out, but I can simplify it. So I'm going to get 1 over 3. Now, do I have another x? So I'm just going to go ahead and put that x up on the top here. I'm going to leave it there. There's nothing I can subtract it with. Do I have the same basis of y? Yes. So I'm going to have to take y to the 3rd divided by y to the 2nd. What do I do to my exponents when I have to divide them? I actually do what to them? I actually do what to them?
Subtract.
Subtract. So what's 3 minus 2?
1.
So y to the 1. Or I could just put y. So on my top, I'm going to have 1xy. On my bottom, I'm going to have 3. So when you're multiplying exponents, what do you actually do to them? When you multiply exponents, what do you actually do to them? You guys, you've got to refer to your notes. When you multiply your exponents, what do you actually do to them? Ben, you're no longer allowed to answer. Yes. When you divide your exponents, what do you actually do to them? Subtract. Okay? All right. Moving right along. Let's look at the next part. Okay. Now we're looking at power to power rule. When any expression is raised to a power, you must blank the powers. So if I'm looking at this expression and it's raised to a power, what am I going to have to do with these two? Multiply. Good. So I'm going to multiply. So we're going to multiply it. I have x squared to the 3rd. So what do?
You multiply the two exponents.
Yeah. So what's that going to equal?
6.
x to the 6th. Now, if it was written like this, would I still multiply my exponents?
Yeah. No.
No, because it's not raised to a power. There, what would I do with my exponents?
You would add.
I would add them. When in doubt, look at your notes, guys. Okay? I have k to the 5th squared. What's that going to equal? K to the 10th. Good, Riley. X to the 6th raised to the power of 7. What's that going to equal? X to the 42. Yes, Ben. Ben's like, please let me answer. Ooh, this is a tricky one. 6/8 to the 1/4 power. What is that going to be?
3.
No?
4.
No.
2.
So, yeah. So how'd you get that chance?
So I just took 1 and
So you took 8 times 1,
yeah,
and then you divided it by?
4.
Good. So we got k to the 2nd power. Questions? Comments? Okay. We're going to keep moving right along then.
I feel like that's going to be multiply.
Yep, we're going to make it in. My head was spinning by the end of the lesson. Okay, distribute. So distributive rule of products and quotients, okay? When any expression is raised to a power, you must blank the power to all the powers, including the what? It's a lot of work there, right? So when any expression is raised to a power, you must, what's it called? You must distribute the power to all the powers, including the, I didn't hear what you said, Ben.
And the exponents.
Including the exponents or the base? I'm going to put it both because you're going to do both of them. Okay? So, what that looks like. If there is more than one variable or there's more than one number in the set of parentheses, we're going to distribute that power to each within the parentheses. Okay? So what that looks like, we're going to take that 3 times 2. What's 3 times 2?
3 times 2 is 6.
Okay? Then we're also going to distribute it to our exponent. So what's x squared times 3 is what?
X squared times.
We're going to what with it? What's 3 times 2? What's 3 times 2? 6. Okay? So basically, you're going to distribute this power to and multiply it by everything on the inside of the parentheses. Okay? So, again, I'm going to distribute that 2 and multiply it by everything on the inside of the parentheses. So what's that answer going to end up looking like, Josh?
Would be H.
To the?
4.
Good. Then,
And K. 20.
what's 5 times 2?
Oh,
10. Nice. Okay. Dylan, give this bottom one a shot for me. So I'm going to distribute the power of 3 to what?
X with the, what's it called?
To the third or cubed. And anywhere else?
More.
Yeah.
To the second.
Okay. And what, when we rewrite that, what is it going to look like then? Once we distribute that, it's going to be x to the what power then?
9.
Very good. Divided by or over y to the what?
That's 6.
Good. Now, because these bases are not the same, there's nothing else that I could do with this. But what if this base down here was x? What would I then have to do? If this base was a x instead of a y, it's dividing. So what would I do? if they divide exponents, what would I actually do to your exponents? Subtract. It's a lot, you guys. I get it. Just keep looking back at your notes, okay? I honestly really like what Mr. Guessford showed me too. That's power stack. And I'll show you that again in just a moment. Okay, big long one, right? So I'm going to take that exponent and that power, excuse me, I'm going to take this power on the outside here and I'm going to distribute it to everything on the inside of my parentheses. That means every term. So my exponent is 2, so I'm going to distribute it to each part. So what's 2 times 5?
10.
Okay? And then I have to multiply it by j. So what's j times 2? J squared, right? Then I multiply it by what? H squared. So what's h squared times power of 2? What's 2 times 2, you guys?
4.
Okay? And then I have to also distribute it to my k. So what's my k going to end up being? 10. Questions on that? No? No-ish? Riley, what do I do with this next one here? Distribute, yeah. So I am basically going to distribute the power of 2 and multiply it by everything on the inside of my parentheses. So what's that answer going to end up being, Riley?
6.
X to the 10th and
12.
y to the 12th. Okay? And then the last one.
4x2.
Oh, no.
No.
Be more specific. Tell me what you're doing.
Multiplying the 2x by the 2.
Okay? Because you distributed. And you got what again?
4x
4x what?
2.
No. 4x2 would be this.
No, 4x top carried.
What's that called? 4x what?
Exponent 2.
Or you could say 4x squared or
Yes.
4x to the second power. Okay? Over.
10.
Because you had to distribute to the bottom as well. Good. So 10 y to the what power?
Squared 8.
No, you're taking 4 times 2, which is 8. So y to the 8th power. Okay? Or to the power of 8, you could say too. Any questions on this part? Do you guys feel okay about it? Thumbs up if you got it. Especially if you could look at your notes and be like, oh yeah, I got to do that. Thumbs in the middle if you're like, okay. Thumbs down if you're like, I don't like this. And I have no idea. And I have no idea what's going on. Can't just say I don't like it.
I mean, like, I know how to do it, but I don't like it.
Okay. Yeah, that's why I had to clarify. Okay. This one is my favorite rule yet. That really surprises me. I just thought you would love it. So, zero exponent rule. Any expression raised to the 0 power is equal to, what does it say there? 1. So x to the 0 power is what?
1.
XYZ to the 0 power is?
1.
A to the 0 power is?
1.
1,500,000 to the 0 power is?
1.
Okay? So anything to the 0 power, you just have to remember that it is 1. Easy enough on that one? Okay.
That should be our homework.
Oh no, I wish. That would be awesome, wouldn't it? It'd be so easy to grade. Okay, now this is where things get complicated. Okay? So negative exponent rule. I know, we have to throw this at you now. Any expression with a negative exponent must move to the opposite side of the fraction bar and turn positive. If you cross the line, you must change the sign. Okay? But that sign stays with that exponent, okay? It doesn't go to the front of the whole fraction. It stays with that exponent. So, for example, we have x negative 2 to the power of negative 2. I can't have a negative exponent, right? So, any expression with a negative exponent must move to the opposite side of the fraction bar. Well, right here, where's my fraction bar?
Right?
Well, remember, any number could really be turned into a fraction by putting it over what? 1. So if my fraction bar is there and my negative exponent's up here, I'm going to have to take it and move it to the opposite side of my fraction bar, which means it's going to go from the top to the... Okay, so if you cross the line, you must change the sign. So if I'm crossing that line, what's my sign going to change to?
Positive.
Yeah, so it's just going to be x squared. Now, I have to have a numerator. What's my numerator going to be? Yeah, just 1. Okay?
It's tricky.
It is. It's really tricky when I give you like 7 exponents and you have to cross some and leave some and everything else. Let's work our way down this. So now I have m squared and then n to the negative 5th power. So my m squared is okay, right? Because it's a positive. But my n negative 5th power is not okay. So what am I going to have to do with that?
Divide by 1.
What am I going to have to, how do I get rid of that negative 5?
Times it by negative 5.
What's the directions? What did our rules say?
Cross the line down.
Yeah, I'm going to cross the line. I'm going to move it to the bottom of my fraction bar. So I have m squared, as Emily said. I'm going to move it to the opposite side of the fraction bar, and I'm going to cross the line. So when I go to cross the line within negative 5, what am I going to do with that negative 5?
Make it a positive.
Yeah, I just make it a positive. So now it's n to the 5th. Okay, so now I have 1 divided by x to the negative 3rd power. That's a problem, again, because I could not have a negative exponent. So to get rid of this negative exponent, I'm going to move it to the opposite side of the fraction bar, which means I'm going to bring it from the bottom to the top. So when I bring it to the top, if I cross a line, I have to change my sign. So if I bring it to the top, what happens to my sign?
It flips.
It just goes to a positive, right? So x to the 3rd power. Now, do I need that over 1 written there? No. Okay? Now, this is where we have to be real careful. This negative 7, the power of the negative 7, what is it referring to? Is it referring to the f, or is it referring to the 4f together?
Yes.
Which one? Say it again. Why do you think both? Because you just had to guess? Because no, it's a guess. Here's how I always remember it. It's like multiplying, right? When we multiply a coefficient to a variable, it's always the number in front of that variable. This negative 7 is touching what? Just the f.
Yep.
So it's just referring to the f. Now, if it was written like this, if it was written as 4f, negative 7, then it would be referring to both. But because it's not written like that, the negative 7, the power of negative 7 is just referring to the f. So when I go to move, because I have to move because I can't have a negative exponent, how am I going to rewrite that? What's going to stay at the top?
4
4. And then what moves across the fraction bar?
over F7.
Up to the what?
7.
Yeah. Good. Okay, Josh.
Yeah.
So we're going to look at this next one together, okay? So I have 5 over x to the negative 5th power. I can't have a negative exponent, can I? To get rid of the negative, what do?
Move it.
Yeah, I just move it to the top. So what's it going to be joining at the top there? What's my number?
5.
5, x what? So you said
Exponent 5.
x to the 5th. That's it. Seems like you should have to do a lot more than just move it, right? Okay, 2 to the negative 3rd. So the negative 3rd, I can't have a negative exponent. So what do I have to do with this 2 to the negative 3rd?
Times it.
No, I cannot have a negative exponent.
Put it on the bottom.
How?
With the X.
So I'm going to put it on the bottom. And if I cross that line, I change my sign, so it's going to just be 2 to the third. What's my numerator?
1.
Okay. Now, can I simplify 1 over 2 to the third power? I can't take 2 times 2 times 2? Yeah, so what's 1 to the over 2 to the third power? What's 2 to the third?
1/8.
There you go.
No.
No.
Oh my gosh.
I told you guys we were going to start having some fun. Hannah's back there smirking like, whatever. Okay. So, your turn.